Hey, Dr. Clark here, coming back at you with another Check Your Understanding video, this one for section 1.2. Let's take a look. The problem asks us about a differential equation. So we've got this differential equation, dy dt equals y over t squared. And they want us to do two things. First, verify that this function here is a solution, basically a family of solutions. You notice the constant c, so for every c, you would get a different function, and so it's a family of solutions. Verify that is a solution, and then solve an initial value problem where they give you the initial condition. All right, so let's do that. First, part A. Let's take a look here what they want us to do. So if the differential equation is dy dt equals y over t squared, and the function they gave us as y of t is c e to the negative 1 over t, is it the case that the derivative is equal to y over t squared? So let's check that. What is the derivative of c e to the negative t, or c e to the negative 1 over t? Well, we're using the chain rule here. The derivative of e to the something is e to the something, and we multiply by the derivative of the something. This is really c e to the minus t to the negative 1, and so the derivative of negative t to the negative 1 would be negative times negative 1, t to the negative 2. And that is equal to, I guess the negatives cancel out, and you have t to the negative 2, so it'd basically be 1 over t squared, essentially. Okay, so that is what dy dt is equal to. And then the question is that equal to y over t squared? Well, what is y? Y is the function, in this case c e to the negative t to the negative 1. Over t squared, and you could write that as c e to the negative t. I guess I could write that as c e to the negative 1 over t times 1 over t squared, because the t squared is in the denominator. And now you can see that this is matching up exactly with that. So yes, this function here solves the differential equation because its derivative is equal to the function y divided by t squared. That checks out. Okay, so yes, it is a solution. That's part A. And then they want us to find a solution to the initial value problem with the initial condition ty equals 2, 0. Okay, so for an initial value problem, we have this general solution, y of t equals c e to the negative 1 over t. And when t is equal to 2, they want y to equal 0. And so we could solve this like so for c. And if we do that, I guess it turns out that c would have to be 0, which means that y of t is equal to 0 with the 0 function. So essentially graphing the function that's just always 0, that's what y of t is. That would be the solution that goes through the point 2, 0. So here's the point 2, 0 right there. That is the solution that passes through the point 2, 0. And that is the solution to the initial value problem with that initial condition. And you can check that it's of this form, right? It just has c equal to 0. And you can also check that it's still a solution because what is the derivative of the 0 function? Well, it would be 0, so this would be 0. And if y is equal to 0, 0 over t squared is also 0, so you do get 0 equals 0. It's definitely a solution, and it passes through the point 2, 0. All right, so that is how you solve that check your understanding problem right there.